Next, come to the point, zircon sand. This is very good sand for making of ferrous and non-ferrous castings, but the cost of the sand is higher than the olivine sand, chromite sand, and silica sand. This is made from uranium, thorium waste, and because of the presence of uranium waste, thorium waste, there may be a little bit of radiation is present. So for that reason, the use of zircon sand is restricted. Only castings used in satellites and other launch vehicles, they use zircon sand because the cost is also high. And but the thing is, there may be a little bit of radiation is present in the zircon sand. For that reason, the zircon sand, use of zircon sand is restricted. Next, come to the point, the types of molding sand. Types of molding sand. Hello.
Sir, the students wait ಮಾಡ್ತಿದ್ದಾರೆ.
ಹೌದಾ? ಓಕೆ, ಒಂದು ಸೆಕೆಂಡ್. ಯಾರು ಇಲ್ಲಲ್ಲಮ್ಮ ಲಿಸ್ಟ್ ಅಲ್ಲಿ?
ಮೆಸೇಜ್ ಹಾಕಿಲ್ಲ. ಹಾ ಸರ್.
ಓಕೆ, ಜಾಯ್ನ್ ಆದ್ರ?
ಎಸ್ ಸರ್, ಆದ್ರು.
ಓಕೆ. See, the molding sand, the types of molding sand. See, once you come to the college, you have the foundry lab. There you can understand what is a dry sand, what is a green sand, and no bake sand. See, the green sand is nothing but the sand which has moisture and clay. Clay means, all of you see, the clay is available in the river bed, lake bed, and this is used for making of the green sand. So the good example for green sand, all of you see Ganesha idol, you know. Every year you have the festival, Ganesha festival. In that, they make the idol of Ganesha god by using clay only. That clay only. Hello.
ಇಲ್ಲೇ ಪಕ್ಕದಲ್ಲಿ ಬಂದ ಅವ್ರ ಹತ್ರ ಬಾಂಡ್ ಇಲ್ಲ, ಇದು ಫೋಟೋ ಕಲರ್ ಪ್ರಿಂಟ್ ತೆಗಿತಾರ, ಇನ್ನೊಂದು ದಪ್ಪ ಬರುತ್ತಣ ಅದಿದ
ಬೇಡ, ಜೆರಾಕ್ಸ್ ಶೀಟ್ ಎಲ್ಲ ಮಾಡಿಸ್ಬಿಡು.
ಜೆರಾಕ್ಸ್ ಶೀಟ್ ಎಲ್ಲ ಮಾಡಿಸ್ಬೇಕಾ? ಅದ್ ಬೇಡ, ದಪ್ಪ ಇರತ್ತಲ್ಲ.
ಅದೆಷ್ಟಂತೆ
ಸರ್? ಇದೆಷ್ಟ ಆಗುತ್ತೆ ಸರ್? ಒಂದು ಪ್ರಿಂಟ್ ಆದ್ರೆ ಲ್ಯಾಮಿನೇಷನ್ ಮಾಡಿ ಬ್ಲ್ಯಾಕ್ ಅಂಡ್ ವೈಟ್ ಇದು ಹಿಂಗ ಅರ್ಧ ಕಟ್ ಮಾಡಿ ಲ್ಯಾಮಿನೇಷನ್ ಮಾಡ್ಬೇಕು. 10 rupees ಆಗುತ್ತೆ.
ಮಾಡಿಸ್ಬಿಡು. A4 ಅರ್ಧ ಶೀಟ್.
ಅದೇ A4 ಅದೇ ಒಂದ್ರಲ್ಲಿ ಎರಡು. ಇವಾಗ ಇನ್ನೊಂದು ಜೆರಾಕ್ಸ್ ಮಾಡಕ್ ಕೊಟ್ಟು ಕಳ್ಸಿದ್ರೆ ಅದೇ ಲ್ಯಾಮಿನೇಷನ್ ಮಾಡ್ಬೇಕಾದ್ರೆ. ಸರಿ ಮಾಡಿ.
See, the riverbed sand, if you add clay and moisture means water, to the riverbed sand, then it becomes a green sand. Next, dry sand. As the sand directly coming from the riverbed, that's called dry sand. Next, no bake sand mold. All of you heard phenol formaldehyde. Phenol formaldehyde chemical solution supplied by Foseco company. The only company throughout the world, the chemical that is a phenol formaldehyde solution supplied by the Foseco company. If you add the phenol formaldehyde solution to the dry sand, then it becomes no bake sand. After mixing the solution with the sand, apply the sand in the mold box and make the mold box within 2 or 3 minutes. Within 2 or 3 minutes. Otherwise, the sand become just like a rock. Just like a rock. In a few minutes, the sand particles bond together and forms the structure, and which makes the rock-like structure. If you touch with bare fingers, you feel touching the rock. So that is the advantage of using no bake sand. So you can make the mold very hard within fraction of a minute, or sometimes it will take minute, so that you can make the mold cavity using pattern or without using pattern. You can make a mold using no bake sand. That is, add phenol formaldehyde solution. First you write down base sand. First you write down base sand. Below that, write down types of base sand. Below that, write down types of base sand. Number 1, silica sand. Number 2, olivine sand. Number 3, chromite sand. Number 4, zircon sand. Number 4, zircon sand. Once again, write down the title, types of base sand. Underline that, put a colon. Below that, write down number 1, silica sand. Number 2, olivine sand. Number 3, chromite sand. Number 4, zircon sand. So this is the explanation for silica sand, olivine sand, chromite sand, and zircon sand. Next, come to the point, how many types of sand molds are available? Write down types of sand molds. Write down the types of sand molds. Underline that, put a colon. Below that, write down. Below that, write down number 1, green sand mold. Green sand mold. Next one, write down number 2, dry sand mold. Number 2, dry sand mold. Number 3, no bake sand mold. No bake sand mold. The green sand mold, all of you observe here in the explanation, which contains the silica sand, clay, water. Clay and water. If required, additives and binders are added to the green sand. Added to the green sand. Next, advantages of green sand. The cost is less, suitable for ferrous and non-ferrous, strength is high, and you can produce a large number of castings, and number of castings are more, and you can produce thin and intricate shapes. Next, come to the point, dry sand mold. Dry sand mold. So this dry sand mold contains only clay and water. Clay and water. And usually the dry sand mold are produced by heating the mold in the furnace about 200 to 300 degrees centigrade for about 6 to 12 hours in the furnace. This is because of there should not be any expansion in the mold cavity. Otherwise, you will not get the exact size and shape of the mold cavity. The dry sand mold are produced by using silica sand, clay, and water after making the mold cavity, which is kept in the furnace for about 6 to 12 hours at the temperature of 200 to 300 degree centigrade. So remember, the green sand mold, it is directly produced from the green sand, clay, and moisture, but dry sand mold, which is placed inside the furnace for about 6 to 12 hours at the temperature of 200 to 300 degrees centigrade. And advantage the dry sand mold, which is stronger than the green sand mold. There is no expansion of the mold cavity, and the molds are very hard and strong, and you can produce large castings are possible. Disadvantages: the cost is high, and the heating process should be carried out in the furnace, and all those things makes the disadvantages of dry sand mold. Next, come to the point, the no bake sand molds. No bake sand molds. Bake means heating the mold in the furnace is not required for this. This is usually the binder resin type is added to the sand. That is called hardener. That is phenol formaldehyde. That is a phenol formaldehyde. So all of you, please write down no bake sand molds, underline that. After that, the hardener. Write down the word hardener, put a hyphen, phenol formaldehyde solution. Phenol formaldehyde solution as hardener. This is the no bake sands are produced by using base sand, binder, hardener, catalyst. All of you write down. First hardener, binder, catalyst, and base sand. The phenol formaldehyde solution added to the base sand, that is nothing but binder and the hardener. The phenol formaldehyde solution works as a binder and hardener. All of you seen araldite. All of you seen the araldite, you know? The araldite looks like a hardener and a binder. The same type of liquid solution is available, supplied by Fesaco company, that is used for making of no bake sand. Next, the advantages of no bake sand, that is all of you understand, that is it is very hard. All of you observe here, which is 50 to 100 times harder than the green sand mold and dry sand mold. And this mold can be used for longer period. So you can use it 1 week, 1 month, or 1 year, or 10 years. So if you keep the mold in the shelf for longer period is better. Longer period is possible. So for that reason, the no bake sand molds are preferred for producing of ferrous and non-ferrous castings. The disadvantages, the first one, the chemicals must be, once if you open the container, you have to use it within half an hour. Otherwise, that becomes hard. Next, the phenol formaldehyde solution is very costlier. Just imagine a liter of phenol formaldehyde solution costs 1,200 rupees. 1 liter. 1 liter of phenol formaldehyde solution costs 1,200 rupees. And that produces some odor and gas. If it is mixed with the sand, reaction takes place and produces some gases and odor, which is a danger to the operator or the man who makes the mold. Sometimes what will happen? Breaking of the mold takes place. If you keep the mold for longer period, there will be a cracks. That is the brittleness usually present in the no bake sand molds. Next, molding sand mixture, ingredients for different sand mixtures. So that is the ingredients used for green sand mixture. That is the base sand, binder, bentonite. It's the bentonite is nothing but clay. All of you write down bentonite. In bracket write down clay binder. Clay binder. Usually the clay binder is added to the green sand with a percentage of 6 to 12%. All of you please write down bentonite plus bentonite you add 6 to 12%. 6 to 12% plus water 3 to 5% plus remaining green sand. And sometimes next you write down additives. Additives. Write down additives, put a colon, write down. The additives are usually used in green sand mold, coal, silica flour, the fine powder of silica flour. Can you name the silica flour you have in your house? Silica flour. All of you know that rangoli hit in Kannada we call it as rangoli hit. That is nothing but silica flour. And wood flour, iron oxide. Write down additives, put a colon, coal, comma, silica flour, comma, wood flour, comma, iron oxide, etc. Iron oxide. For that, you make it subdivision A, write down the title, ingredients for green sand mixture. Ingredients for green sand mixture. Next, you write down number subdivision B, ingredients for no bake sand mixture. Ingredients for no bake sand mixture. Underline that. Use first you write down base sand, colon, silica sand, plus sodium silicate binder, below the write down the alkyd binder system consists of 3 parts. In the top write down binder, underline that. The alkyd binder system consists of 3 parts. Below that write down part A binder. Part A binder, put a hyphen, sodium silicate. Next line write down part B, in bracket write down hardener, hyphen.
Hello.
Hello.
Sir, the Furan system ಅಂದ್ರೆ ಏನು ಸರ್ ಅದು?
ಫ್ಯೂರನ್ ಸಿಸ್ಟಮ್ ಅಂತಂದ್ರೆ ಈ ಕೆಮಿಕಲ್ಸ್ ಬರುತ್ತೆ, ಫಿನಾಲ್ ಫಾರ್ಮಾಲ್ಡಿಹೈಡ್ ಸೊಲ್ಯೂಷನ್ ಟೈಪ್ ಕೆಮಿಕಲ್ಸ್ ಬರುತ್ತೆ. ಅದರಲ್ಲಿ ಆ ಲಿಕ್ವಿಡ್ ಅನ್ನ ಸ್ಯಾಂಡಿಗೆ ಹಾಕ್ಬಿಟ್ಟು ಅದನ್ನ ಫರ್ನೆಸ್ ಅಲ್ಲಿ ಇಡ್ತಾರೆ, ಡಿಪೆಂಡಿಂಗ್ ಅಪಾನ್ ಸೈಜ್ ಆಫ್ ದ ಕಾಸ್ಟಿಂಗ್ ರಿಕ್ವೈರ್ಡ್. Furan anta. It is developed in the country Furan, or that it is called as a Furan system. So if you want more details about this, you refer metal casting by O.P. Khanna.
O.P. Khanna, okay, sir.
O.P. Khanna, or one more foreign author book is there. Afterwards, I will tell you. In that book, they have defined a Furan system for steel casting. Okay. Next, you write down part C. Part B, hardener - phenol formaldehyde solution. Hardener - phenol formaldehyde solution. Close the bracket. Next line, write down part C. Catalyst. Catalyst. Put a hyphen. Methylene diphenyl diisocyanate. All of you write down. It is called as MDI. MDI. Methylene diphenyl diisocyanate. In bracket, write down MDI. In foundry, usually they call it as MDI solution. Write down catalyst, put a hyphen. MDI, methylene diphenyl diisocyanate. Usually, the catalyst may be 20 to 25% of weight of the binder used. Weight of the binder used. Once again, the part A, binder, usually sodium silicate. Part B, hardener, phenol formaldehyde solution. Part C, catalyst, that is the methylene diphenyl diisocyanate solution. In bracket, write down MDI solution. This is called as catalyst. Next, come to the point. All of you write down methods used for sand molding, or you can write down different types of sand molding. Write down methods used for sand molding. Underline that. Methods used for sand molding. First, write down bench molding. Say, the name itself indicates bench. In our college, in foundry, we are carrying out the mold making process on the bench. Usually, this bench is made from concrete slab, bench molding. At the height of 2 to 2.5 feet height, they keep the concrete slab of 2 by 5, 2 feet by 5 feet length. So on that, they carry out the molding process that is called bench molding. Next, floor molding. The molding process is carried out on the floor. The name itself indicates the process is carried out on the floor. It is called floor molding. Next, come to the point, pit molding. They make the hole. They make the pit in the floor. Make the pit hole in the floor, and they keep the mold box inside the pit, in the hole, in the pit, in the floor. That is called pit molding. All of you please write down. Number 1, bench molding. Number 2, floor molding. Number 3, pit molding. Pit molding means they make the pit inside the floor. The name itself indicates pit, hole made inside the floor. In that they keep the mold box, or sometimes they create the as it is the mold cavity. They prepare the mold cavity in the floor as it is. Sometimes they keep the mold box inside the pit. So that is called number 1, bench molding, floor molding, pit molding. Next, come to the point, machine molding. Machine molding. This is the jolt squeezing machine. Jolt squeeze molding machine. All of you observe here. This is the machine used in the foundry for making of mold box. All of you observe here. This is cope and this is track. This is the mold cope filled with sand, and the board is pressed on the sand. This is the upper portion of the machine which moves downward direction. The table supports the drag portion of the mold box, or if I keep the cope or drag on the table, you can squeeze, pressing the number, the name itself indicates squeeze, jolt squeeze. That is the pressing of the sand inside the cope. And this is the board used for supporting the drag and cope. You can make the drag and the cope simultaneously by using jolt squeezing machine. So this is the machine used in the foundry for making of mold box. Say the one person for making of cope and drag, he may take 4 to 5 hours. Remember, he want to suppose the human being used for making of drag and cope of the mold, simple casting mold, he take 3 to 4 hours. The same mold can be produced within 5 minutes. Imagine, within 5 minutes, if you use jolt squeezing machine, jolt squeeze molding machine, if you use, you can produce within 5 minutes or within 3 minutes, you can produce the mold. And next, ramming the mold sand. See, as you seen the machine, the ramming takes place by using the plunger along with the squeeze bore, which presses the sand inside the mold box. That is nothing but ramming the molding sand in the mold box. Next, core. Suppose if you need hole in the casting, the cores are produced. The cores may be produced by using core shooting machine, or you can prepare the core by using hand. That is called manually. You can produce the core. All of you see the chalk piece. The same type of cores are produced, and the bottom they use some washer type of core seat or core print. They keep the core print in the exact position inside the mold cavity by using nail. You have seen the nail, steel nail. By using the nail, they place the core print in the exactly in the perfect position, and after that they fix the cores. And next, come to the point. All of you write down cores. I think you finished machine molding and machine molding. After that, write down cores. Write down the title cores. Next, you write down types of cores. Types of cores. So underline that. Types of cores broadly classified into 2: clean sand core, dry sand core. Dry sand core. And the cores are classified based on other classification. condition of the core, binder used, as I told you, a resin, that is phenol formaldehyde solution or a sodium silicate, or sometimes they use oil for bonding of the sand particles for making of the cores. Next, hardening process. See here, the carbon dioxide process is used for making of the hardening of the core. So these are the condition of the core. These are the condition of the core, that is the green sand core, dry sand core, and the type of binder used and the hardening process. Next, come to the point, the shape and position of the core. So if you place the core inside the mold cavity in horizontal direction or vertical direction, or in sometimes balanced position in the mold cavity or hanging core. So this is very much essential for producing hole in the casting. Next, this is the write down green sand core, write down green sand core, underline that. The binder is used in the making of green sand core, that is called NO9, and moisture. Next, dry sand core, dry sand core. So all of you seen the Portland cement we are using for construction. The same type of cement is available for making of dry sand core, and sometimes they use sodium silicate, linseed oil, mineral oil, and natural resins used for making of dry sand core. Next, you write down binder used, hardening process used for making of the core. If you write this much, enough for the examination. Next, come to the point. Say if you place the core horizontal position, that is called horizontal core. And if you place the core in vertical direction, that is called vertical core. Sometimes if you place the core in the potting line, that is called balanced core. Next, the hanging core, usually using wire, steel wires, they place the core inside the mold cavity by hanging from the top, that is called hanging core. Hanging core. Next, many other types of core. This is the drop core. The name itself indicates drop, that is the core which is dropped inside the mold cavity. And the kiss core, if you need more holes in the casting, they use the kiss cores. Next, ram up core. This is the hole produced in the casting. The sand is run inside the mold cavity for making of the hole in the casting. That's called ram up core. So suppose you have this question in the examination, to write any four, maybe horizontal core, vertical core, balanced core, hanging core, drop core, kiss core, and the ram up core. So if you write any four, that is enough for 5 marks. Next, method of making core. How do you make the core? So that is one, the cores are produced. All of you write down method of making cores. Method of making cores. And write down core making consists of the following 4 steps. Write down one by one. Number 1, core sand preparation. Next line, number 2, core making. Next line, number 3, core baking. Next line, number 4, core finishing. First step, the core sand preparation. The core may be prepared by using dry sand. Add the clay, water, and additives and a binder and prepare the sand. Then the shape of the hole required, either it may be a square hole, circular hole, depending upon the type of hole required. According to that, prepare the core. Next, the core core box. How do you produce the core? Whether it may be circular one or square one or any other shape. And this is the jolt squeezing machine, as I explained earlier, for making of the mold box. Next, all of you observe here. This is the bench. On that, they are making the core. And this is the core box. This is the core plate. And this is the square, rectangular shape of core. If you place this inside the mold cavity, which leaves the shape like this in the casting. So that is, this is the rectangular core. This is the core making. And after making this core, keep the core, if required, in the furnace for about 93 to 232 degrees centigrade, about half an hour or 1 hour in the furnace, so that the core becomes very, very hard. Next, afterwards, then paint the core with the paint or clay or the other projected or unwanted sand particles present on the core that should be removed by using core finishing, by using chiseling or filing. You can remove the unwanted sand or unwanted projections are present in the core. After that, the cores are dried in the air before placing inside the mold cavity. Now you write down the 4 steps: method of making cores, cores and preparation, core making, core baking, core finishing. You have the explanation here for core baking, core finishing. Next, come to the point. Gating system. Gating system. All of you write down gating system. All of you take the screenshot or write down the rough diagram. Write down the rough diagram. Write down the rough diagram. Say the below that, write down elements of the gating system. Elements of the gating system. Elements of the gating system. Underline that. This is the pouring cup. This is the sprue, or it is also called as down sprue or down head. You remember, this is sprue. This is sprue. And this is the sprue base. Sprue base, or it is also called as sprue well. The liquid metal stored in the bottom of the sprue well. After filling the sprue base flows inside the runner. This is the long portion which is called runner, which is connected by number of gates. Gate number 1, 2, 3. Gate number 1, gate number 2, gate number 3. All the 3 gates are connected to the mold cavity. Mold cavity. All the 3 gates are connected to a mold cavity. From the bottom, there will be one more gate which is connected to the riser. Connected to the riser. You tell me, if you pour the liquid molten metal, what is the action which fills the sprue well? If you pour the liquid metal in the pouring cup, flows through the sprue, fills the sprue well, flows inside the runner, again flows inside the gate, and completes and fills the mold cavity within 2 to 3 minutes. If it is 5 to 100 kgs of casting, If it is 1 ton casting of cast iron, which fills the mold cavity within 5 to 10 minutes after filling the mold cavity, again the liquid metal flows into the gate and fills the riser. Say all of you observed in your house overhead tank. Along with the overhead tank, there will be a pipe, air pipe. All of you seen the same height of the tank height. There will be a air pipe. In the same way, here they use the riser as the air pipe. The riser works as a governor in the casting process. As the liquid metal changes from liquid phase to solid phase, there will be volume contraction. Volume contraction. The mold cavity still requires little amount of liquid metal in order to fill the mold cavity, in order to fill all the parts of the mold cavity or the complete the mold cavity, in order to compensate the volume contraction. Due to the volume contraction, the mold cavity requires little amount of metal that is supplied by the riser. Remember, the amount of metal is supplied to the mold cavity in order to compensate the volume contraction. This is very, very important. All of you mark it very important. At this time, you have this question in the examination. Please, all of you, write down the question. You have this question in the second portion of the module 1. Second question, explain briefly with the neat sketch. Explain briefly with neat sketch the elements of a gating system. Elements of a gating system. Mark it very important. This time you have this question in the examination, 100% guaranteed. Now I stop at this stage. I will continue in the next class. Now all of you please write down your name and USN in the chat box and answer or call. All of you unmute yourselves. Mithun Naik, Nazma.
Present, sir.
Yes, sir.
Shahid. Shahid. Dhananjay.
Yes, sir.
Mohan Raj. Dawood.
Present, sir.
Dawood Rasul.
Present, sir.
Chhatrapati.
Yes, sir.
Harshavardhan. Ashwin.
Yes, sir.
Karthik.
Yes,
M.
sir. Sir.
Darshan.
Hello, sir. Harshavardhan present, sir.
Okay.
Present, sir.
Okay.
So, Darshan present, sir.
Okay. Prathamesh.
Yes, sir.
Aditya. Mohammad Raja. Vivekanand.
Present, sir.
Vignesh. Danesh.
Yes, sir.
Hemant.
Yes, sir.
Nishchit Gowda.
Present, sir.
Akshay M. Patil.
Present, sir.
Sushin. Sushant.
Yes, sir. Yes, sir.
Manoj YB.
Yes, sir.
Kumar Swami. Pawan HR.
Present, sir.
Chandan RC.
Yes, sir.
Krutik.
Yes, sir.
Viram.
Yes, sir.
Ganesh Naik.
Present, sir.
Pratik. Karthik MK.
Yes, sir.
Shashank.
Yes, sir.
Hemant.
Present, sir.
Harsha MR.
Present, sir.
Nayad Sharif.
Yes, sir. Yes, sir.
Madhusudan. Danush. Bhagat.
Yes, sir.
Yes, sir.
Nikhil Gowda.
Yes, sir.
Akash, Karthik,
Present, sir.
Lohit Kumar, Jishan,
Yes, sir.
Jitendra,
Yes, sir.
Abhilash, Chetan,
Present, sir.
ಮನೋಜ್ ಎಷ್ಟು ಸಲ ಬರೀತೀರಾ? ಗಣೇಶ್ ನಾಯಕ್, ಅಭಿಲಾಷ್,
Present, sir.
ಚಂದನ್ ಆರ್ಸಿ, ಮೋಹನ್ ಆರ್ಸಿ, ಮೋಹನ್ ರಾಜ್ ಎಂಬಿ,
Present, sir.
ಮೊಹಮ್ಮದ್ ರಾಜಾ.
Yes, sir.
Anybody else? Anybody
Sir,
else?
Karthik.
Please tell your name.
Sir,
Vignesh HV.
Okay. Vignesh HV.
Karthik.
Okay. Next.
Karthik AM.
Karthik AM. Okay.
Sharat, sir.
Nutan.
Okay.
Nutan, sir.
Nutan. Okay. Next.
Sir, Nash Sharif.
Nash Sharif. Okay.
Sir.
Now I stop at this stage.
Hello.
Anybody else still? Okay, I'll stop at this stage. I will continue in the. Sharath. Okay, pa. Okay, pa. Next.
Hello.
ಸರ್
ಹೇಳಮ್ಮ.
ಸರ್ ಆಕಾಶ್ ಆರ್ ಕೆ ಮಾರ್ಕ್ ಮಾಡಿಲ್ಲ ಸರ್.
ಆಕಾಶ್ ಆರ್ ಕೆ. ಓಕೆ. ಮಾರ್ಕ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ.
ಥ್ಯಾಂಕ್ ಯು.